Lee Pound, and today we'll be tackling the AP level question on our statistics quiz number 2. The question states, two parents have each built a toy catapult for the use in a game at an elementary school fair. To play the game, students will attempt to launch ping pong balls from the catapult so that the balls land within a 5-centimeter band. A target line will be drawn through the middle of the band as shown in the figure below. All points on the target line are equidistant from the launching location. If a ball lands within the shaded band, the student will win a prize. The parents have constructed two catapults according to slightly different plans. They want to test these catapults before building additional ones. Under identical conditions, the parents launch 40 ping pong balls from each catapult and measure the distance that the ball travels before landing. Distances to the nearest centimeter are graphed in the dot plots below. We know the context of the problem, we can move on to part A, which says, comment on any of the similarities and any of the differences, the two distributions of distances traveled by the balls launched from catapult A and B. One of the easiest methods for describing distributions is just using this acronym, SOCS, that stands for Shape, Outliers, Center, and Spread. So that's what I did next. I used the SOCS acronym to compare and contrast catapult A and B. As far as shape goes, they are pretty similar. Both fairly symmetric with a single mound at the center. They both had that nice curved shape. At outliers, it became a little different. Catapult A had some potential outliers at both the beginning and the end, whereas Catapult B had no outliers. It was fairly compact. At center, they were also pretty similar, but Catapult A's center was a median of 136, which was a little bit lower than Catapult B's median, which was at 138 centimeters. As far as spread goes, Catapult A had a much larger range of 122 to 155 centimeters and more variability between data points, so you can see a lot of space between here and over here. Catapult B had a much smaller range from 133 to 144 and a lot less variability. Like we said before, most of its data point was all compacted in one single place. Move on to part B, which asks, if the parents want to maximize the probability of having the ping pong balls land within the band, which of the two catapults would be better to use than the other? Knowing what we do from our SOCS analysis in part A, we can confidently say that if Catapult B was placed the right distance away, it would be the best choice because the distance of the balls vary less from the center than when Catapult A is used, which makes for a much higher probability the balls will land in the target zone. You can see this on the graphs as well if you look at the 5-centimeter range on both that has the highest number of distances plotted. Catapult A's 5-centimeter range only has 26 of the 40, while Catapult B's 5-centimeter range has 30 of the 40 attempts. Next we can move on to part C, which simply asks, using the catapult you chose in part B, how many centimeters from the target line should this catapult be placed? Explain. In order to solve this, all we have to do is locate the center of the 5-centimeter range of Catapult B we found in part B. So if we look here, the range is from 136 to 140, so that we know the middle value of that would be 138. So that is our final answer for part C. We want to place Catapult B 138 centimeters away from the target line to maximize the number of balls landing within the target zone.